L, M and N are three parallel lines intersected by transversal P and Q such that L, M and N cut off equal intercepts AB and BC on P. Show that L, M and N cut off equal intercepts DE and EF on Q also. In this question, we are given that L, M and N, these are three parallel lines and P and Q are the two transversals. Now, it is given that AB is equal to BC because the intercepts AB and BC are equal on the transversal P, and we have to prove that DE is also equal to EF. For that, first let's see the midpoint theorem of a triangle. We will explain first the midpoint theorem of a triangle. For that, let's first draw a triangle. This is a triangle A, B and C. Now, the midpoint theorem of a triangle says that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of the third side. That is, if we are taking the midpoint of AB and AC, let D is the midpoint of AB and E is the midpoint of AC. Now, if we join the midpoint of two sides of a triangle, then we will get DE and this will be parallel to BC, that is the third side of a triangle, and it will be also equal to half of the third side. That is, the midpoint theorem says that joining the midpoint of any two sides of a triangle, it will be parallel to the third side and it will also be half of the third side. Now, the converse of midpoint theorem says that the line drawn through the midpoint of one side of a triangle and parallel to another side bisects the third side. That is, if we are taking D as the midpoint of one side of a triangle and if we say that DE is parallel to BC, then DE will also bisect the third side, that is AC. Let me note it down also. That is the converse of midpoint theorem. According to this, if D is midpoint of AB and DE is parallel to the second side, let it be BC, then according to converse of midpoint theorem, it will say that E is also the midpoint of AC. That is, DE will also bisect the third side. Now, applying these results on the question given, if we take triangle ACF, that is, in triangle ACF, this one, we are given that AB and BC are equal. That is, AB is equal to BC. This implies that B is midpoint of AC. As AB is equal to BC, it implies that B is the midpoint of AC. Now, we are also given that M is parallel to N. As L, M, N are all parallel, therefore M is also parallel to N, which means BG is parallel to CF. So, we can say that as B is the midpoint of AC and BG is parallel to CF, that is, according to converse of midpoint theorem, G will also be the midpoint of AF. So we can write it as AG is equal to GF because G was the midpoint of AF. Now we will take another triangle ADF. That is, in triangle ADF, we have proved that AG is equal to GF. AG is equal to GF, or we can say that G is the midpoint of AF. Now, as L, M, N are all parallel lines, therefore L is also parallel to M, or we can say GE is parallel to AD. GE is parallel to AD. So we have GE parallel to AD and G midpoint of AF. Therefore, according to converse of midpoint theorem, we can say that GE will also bisect DF, that is, DE will be equal to EF. So we can say that L, M and N cut off equal intercepts DE and EF on Q also.